Nearly 12 billion menstrual pads are sent to landfills within the US alone each year. The key plastics within these pads, polyethylene and polypropylene, take upwards of 800 years to degrade and never truly degrade. They just become microplastics, which then end up in water sources. So our Capstone project aims to design a practical and sustainable repurposing and recycling solution to extract the key plastics from these pads and turn them into something useful.
In a pilot scale process, the first step would be taking in our used pads and using a custom-made sterilization tank to sterilize the pads. For our experimental purposes, we're starting with clean pads, and we're using xylene to dissolve the pads under heat for 8 to 10 hours to extract the polyethylene and the polypropylene.
So after we pour our xylene into our pads, we let them dissolve for 8 to 10 hours at 90 degrees Celsius. This is what the setup looks like. After that, into our xylene plus dissolved plastic mixture, we add coal acetone in order to reprecipitate the plastics that is dissolved in the xylene and acetone. After that, we do a simple vacuum filtration step in order to recover those plastics. And after vacuum filtration, we recover plastics which look like this.
Using our recovered plastics, which are polyethylene and polypropylene, we explored two different avenues. The first is catalytic depolymerization, where we turned our recovered plastics into short-chain fuel additives. The second is injection molding, where we turned our recovered plastics into plastic pads such as this. Performing a life cycle assessment, we found that overall our process was more environmentally friendly than existing disposal methods such as incineration. Furthermore, we also performed an economic assessment and found that our process is profitable.
All in all, tackling this design project was eye-opening, challenging, yet very rewarding, and we're excited to see where the future takes us.
A big thank you to our professors, Professor Elizabeth Prince and Eric Fraze.